Today we're going to talk about section 9.8, modeling using some quadratic functions. Our objective today is to write quadratic equations from given data. So the first example we're going to do is finding the quadratic function that fits the set of data points. So we're given a graph here, and what we want to do is find some points from this graph and then plug it into our quadratic function and find out what it actually equals. So the first thing here is we can select some ordered pairs. We have 1, 0. We have another good ordered pair there, knowing it intersects there at 2, 1. And we have another one here at 0, 1. Now there's other ones you could use, but those are the three that I'm going to use for this problem. And when we do this, we know that our standard form of a quadratic function is ax squared plus bx plus c equals f of x. And we need to find out what the numbers are here that are going to go in for a, b, and c to give us our equation. Well, what we do know here is we have a set of x's and we have a set of y's that we could plug in. And remember, f of x is basically the same thing as saying y equals ax squared plus bx plus c. So we're going to plug in those ordered pairs into our equation and see what that results in. So the first one we're going to do is plug 1 and 0 in. So we're going to plug 0 in for y and 1 in for x. And then our second one, we're going to plug in 1 for y and 2 for x. And then for our last one, we're going to plug in 1 and 0. So we can go ahead and simplify these now. And for that first one that we did, I can scroll down. We get 0 equals 1a plus 1b plus 1c. And then for the second one, we're going to get 1 equals 4a plus 2b plus c. And then for the last one, we're going to get 1 equals 0a, 0b, and 0c. Now we have here, I'm sorry, not 0c, 1c. Now what we have here is 3 equations for 3 variables, and we can eliminate those. We find out that c automatically equals 1. And then there's some options we could do in order to find out the other letters a and b. We could do some elimination, find a and b. We could also do a matrices if we needed to. But for this case, we could just go ahead and do elimination, plugging 1 in for c. So now this is a plus b plus 1 equals 0, 4a plus 2b plus 1 equals 1. And then when we move everything to the other side, a plus b equals -1, 4a plus 2b equals -1. And then we can multiply a row by 2. So why don't you go ahead and finish that, find a and b. So when you solve this system here of a plus b equals -1 and 4a plus 2b equals 0, we can get a equals 1 and b equals -2. With our c value being 1, so we can go ahead and plug those values back into our ax squared plus bx plus c and get an equation of f of x equals x squared, the 1 for the a, minus 2x plus 1. Now we could do that if we are not given a graph either. We could just plug in the ordered pairs. So if we take our f of x equals ax squared plus bx plus c. Go ahead and take a minute, pause the video, plug in 1 for x and 6 for y, and then etc. for the other points, and set up your 3 equations. So these over here are the 3 that you're going to get when you're plugging in the ordered pairs. And then when you simplify that to the 1 squared times a, you're going to get the 1a. 1 times b, and you're going to get your 1b, plus your 1c equals 6. Simplify over here, you're going to get negative 2 squared, which is 4a, negative 2 times b, which is negative 2b, and etc., and you're going to get your 3 equations. In order to solve for the 3 equations, what I would recommend is setting up a matrix. So if you have your graphing calculator, and then we're going to go into matrices. So we go into matrices. We want to edit the matrix, and it is a 3 by 4. So remember, we're going to type in just the coefficients. So on that first row, it was 1a and 1b and 1c equals 6. And then on the next one, it was 4a and negative 2b and 1c equals 3. And then on the last one, it was 9a, 3b, 1c equals 18. Once you get that all in, we can go back to the main screen. And then if we recall, we want to go back into matrix. Now we want to go over to, or down, I'm sorry, math, down to RREF. Press enter on that one, and then we want to recall the matrix that we selected, which was matrix A. So go back into matrix, and we put it's under matrix A. And it will tell us our answers, which is going to tell us that A is 1, B is 2, C is 3. So we go back into our notes here and say that A is 1, B is 2, and C is 3. Plug that into our equation right here. And we find out that f of x equals x squared plus 2x plus 3. So there are going to be times where you're going to want to use maybe say elimination, and there's going to be other times you're going to want to set it up using matrices. We could also look at some word problems. A model rocket is fired upward. At the end of the fuel burn, it has an upward velocity of 49 meters per second and is 155 meters high. Find the maximum height when it happens. The first thing we should probably recall is the formula that we're going to be using. And then plug in the information that we do know. We do know that it had that initial velocity of 49 and 155 meters high. So we can plug in the information that we know. And then if we recall setting this up to find the maximum height, we know that if it has a maximum, that it would be a downward graph here. But we need to set it up, and what we talked about a couple days ago was completing the square, and we can factor out the common of just the first 2. So if we factor out here a negative 4.9, we're left with t squared minus 10t. I'm going to leave that blank so that we can complete the square. And we're going to keep the 155 separate. And now what we're going to look to do is complete the square, because again, finding the maximum means it's a downward graph, and also we want to find the vertex. We're going to be putting it into vertex form. So when we do that, we're going to take half of negative 10, which is negative 5, so t minus 5 squared. And then 5 squared is 25, but we didn't really add 25. Remember, we did negative 4.9 times 25, so we need to do positive 4.9 times 25 to keep the problem equal. And when we add that to the 155, because this comes out to 122.5, we have plus 277.5. And it's now set up in vertex form for us, which tells us that 5 comma 277.5, which tells us that we had a maximum height of 277.5 meters, and it also asks when it happened. Tells us right here when it happened. We were plugging in for time, so it happened at 5 seconds. We could also then find out when the rocket will reach the ground. Well, when will the rocket reach the ground? The rocket will reach the ground. Well, first of all, let's take our equation that we just solved for. That deals with the rocket. We're finding out when the rocket reaches the ground. We're finding out when it will have a height of 0. So now we just need to solve this, and because we have this group with the t, we're going to try to isolate that, so we're going to subtract the 277.5. And then to isolate the t, we can divide both sides by the negative 4.9. We're going to get t minus 5 squared over 277.5 over 4.9. You can find out what that decimal is. And then we would take the square root of both sides. And we're going to get t minus 5 equals approximately plus or minus 7.525. And then we need to add 5 to both sides in order to solve for t. And technically it's plus or minus, but we know that time can't be negative, so we're going to need to get rid of that negative. And we're going to say that it's approximately 12.525 seconds. And that concludes the notes for section 9.8.